Hello students, good morning. Today we will start our next topic, that is power. What is power? Power is a rate of doing work is known as a power. Power, rate of doing work is called power. Then power we can say that work done per unit time. Then you can say work 1 watt equal to 1 joule per second. Then power of the agent is said to be 1 watt if there does the work is a 1 joule in 1 second. That is, the power of an agent is said to be 1 watt if it does a work of 1 joule in 1 second. That is power. Then 1 horsepower is equal to 746 watt. Clear? HP means horsepower. Clear? And power, it is a scalar quantity. It is a scalar quantity, not vector quantity. It is scalar quantity. And 1 electric volt, then unit, practical unit of energy, you can write there, practical unit of energy, that is 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 joule. 1 electric volt equal to 1.6 into 10 raised to power minus 19 joule. Now next, our mass energy relation. Then E equal to del mc square. Then del m is the mass appear or disappear, known as the mass defect, and E is the energy disappear appear, and C is the speed of light, where del m mass defect and C is the speed of light. That means that is 3 into 10 raised to power 8 meter per 3 into 10 raised to power meter per second. Everyone know about it. Next, our topic, that is collision. What is collision? Everyone know about the meaning of this word. Collision means takrana. That is the incident force exerted on each other in relatively large in relatively short duration during of the time. That is the collision. It is an isolated event in which force exerted on each other is relatively large in the relatively short duration of time. That is a collision. There type of collision, there are 2 type of the collision. One is elastic collision and second is the inelastic collision. Types of collision. First is elastic collision. The collision which does not involve any loss of kinetic energy. That is, kinetic energy remains conserved. Kinetic energy remains conserved. Clear? It obeys conservation of linear momentum. It obeys of law of conservation of linear momentum and obey law of conservation of total energy, and this one conservation of law of conservation of kinetic energy also, of kinetic energy, that is the elastic collision, which involve the law of the conservation of the linear momentum, law of conservation of total energy, law of conservation of kinetic energy. Second, our in elastic collision, second type of the collision, that is the involve loss of the kinetic energy. The collision which involve loss of kinetic energy. The forces may be conservative and non-conservative together, and all forces are non-conservative. Clear? Now coefficient of restitution. Coefficient of restitution. What is coefficient of restitution? When we are taking there two objects whose mass is m1 and m2 and both are collide with each other, then after this one, then their velocity will change. Before this one, let we are taking their velocity is u1 of m1 mass and u2 is a velocity of m2 mass. Then after collision, its velocity will change, that is v1 and v2 respectively. Then coefficient of the restitution, that is we will denote with the letter E, small e letter. Then it will be ratio of the relative velocity after collision to the relative velocity of the before collision. That is ratio is known as a coefficient of restitution. Here we will take m1. Here this one is a moving with velocity u1. Then m2 mass we are taking. Here velocity of this object is u2. Then u1 is greater than u2. Then here we can say u2 is greater than u1. Then here this one is the condition before collision. After some time they will collide with each other. They collide with each other, m1, m2. Then after collision, then here m1 its velocity become v1 and their velocity become of m2 become v2. Clear? Then we can write their v2 velocity is greater than v1 velocity. This one is after collision. Clear now? Then we can say it is the ratio of relative velocity of separation after collision to relative velocity of approach before collision. Clear? Then coefficient of restitution mathematical form we can write there. E we will denote that coefficient of restitution. Then this we can write that is the ratio of the after collision velocity then the before collision velocity. Clear now? Then for perfectly there, this according to coefficient of restitution we can divide, that is a type of the collision, that is a perfect elastic or inelastic. Clear? How we can write this one? case first. If 4 perfectly elastic collision, then we can say if E equal to 0. For E equal to 0, if this ratio is coming 1, then we can say that it is the perfectly elastic collision. Next case we can say case 2, 4 perfectly inelastic collision. That means object will not be separated after collision. Then means you can say V2 minus V1 equal to our 0. So we can say E equal to 0 for our perfectly inelastic. Now case 3, if not equal to 0, not equal to 1, then perfectly E used between 0 and 1 for the elastic collision. Clear now? Up to this topic, complete your notebook. Next topic, elastic collision in one dimension and proof of this. How we can write this ratio, that is a E equal to this ratio, U1 minus U2, this ratio. Proof of this one we will do tomorrow. Up to this topic, complete your notebook and learn it. Okay, thank you.